looking at quadrilateral characteristics. We talked about quadrilateral characteristics on day 1. This is the back of our day 1 notes. We went through all the different properties, like these are the properties of a parallelogram, these are the properties of a rhombus, but they also include everything from the parallelogram. So this flowchart is going to be very helpful in deciding what we're doing to solve these problems today. So now we're going to apply these problems with some algebra. So we're going to, or not algebra today, but just finding values, finding angles, finding segments, things like that. So let's take a look and fill in some of the things that they gave us. They gave us x, y is 15. They gave us wx is 22. Vx, the whole length from here to here, is 52. And wt is 23. Lots of numbers here. Alright, so let's use all that information to find sides, okay, or segment length. One thing we know about the keyword here, they always give you a description in the title of what this one is. This one's called a parallelogram. So I would suggest looking at the sheet. Okay, with parallelograms, we know opposite sides are parallel, opposite sides are congruent, diagonals bisect each other. So those are some key things we would need to know for that. I would suggest making flashcards of these. If you make a flashcard for a rhombus, it needs to include these 3 things plus these things up here, because a rhombus is a special parallelogram. Okay? So, in this picture, ZW is the left-hand side, so ZW should match the right-hand side. So this will be 15, because opposite sides are congruent. Okay, so ZY should be 22. Again, opposite sides are congruent. TX, so that is just this part here. If the whole length is 52, it says diagonals bisect each other. So half of 52 is 26. Okay, so kind of the opposite idea, if WT is 23 and we want WY, we would just times that by 2. So this would be 46. Okay, so that's everything related to the segments. Now let's look at angles. The angles they gave us following the load W, Z, Y. So this whole angle down in this corner, I'm just going to draw an arrow, this angle is 72 degrees. Alright, WXT, this angle right in here, just that little part of that angle is 35 degrees. And ZWT, this little part of this angle here is 59 degrees. Alright, so some key features with angles. We know opposite angles are congruent. We also know that consecutive angles are supplementary. I'll just, instead of writing out the word supplementary, I'm going to say consecutive angles are 180 degrees, because that's what supplementary means. They add up to 180. So let's see. We have angles TZY. TZY. This angle right here is what we're trying to find. Okay, so one thing we do know is these lines are parallel. So if you look up here, this angle here should match that angle there. So we know if that's 35, this one has to be 35. And I'm just going to write over here, the reason I knew that is because those were alternate interior angles. So parallel lines can still play a factor in these, because opposite sides are parallel. Okay, let's see, X, Y, Z. X, Y, maybe I did that wrong. X, Y, Z. this whole angle down in this corner, basically at angle Y. Well, if we know this whole angle is 72, we can know that these two are consecutive angles, so 180 minus 72 gives us 108. So that was the consecutive angle thing. Let's see, XWT. Well, I kind of know that this angle here, W, there's a couple different ways to do this, but I figured out if this is 108, because this one's 108 and opposite angles are congruent, I'm going to take 108 minus 59 and figure out what the other side of that one is. And that is 49 degrees. Or you can take 72 from 180 and then minus another 59, and what would be left was 49. Alright, let's look at the next one. XYT. So this angle right here. XYT. There's lots of ways to do this, but I noticed this angle here would be alternate interior with that angle up there, so this is going to be 59 degrees. So using all the properties of a parallelogram to find segments and angles. Okay, this one we're going to focus on a rectangle. Rectangles have all the properties of a parallelogram, but now we're going to look specifically at rectangles. So let's see, they told us DB is 42. That whole length is 42. AD is 26. And angle DAE is 52. I'll put a little degree sign there. Alright, so what do we know about rectangles? We know they all have 90-degree angles. We know opposite sides are congruent. If this is a right angle, I'm sure you guys have heard of it, but Pythagorean theorem. It's how you can find the missing side of a right triangle. So if I was going to draw that top part of the triangle out, oops, that's not a very good right angle, but this is 26, the diagonal is 42, and let's say I want to find this. That could be the same number as the top of the picture or the bottom of the picture. So Pythagorean theorem, the hypotenuse is always a C, so the diagonal is your C value. The A and B, it doesn't really matter because you're just going to add these two numbers together. So you have to square them first. And then to solve for x, you'll subtract the 676 to the other side. You get 1088. And then we're going to square root that number. And in decimal form, that would be 32.98, so about 33. If you are asked to simplify the answer, we want to find the biggest perfect square that goes into 1088. I could give you some time to work on that. Perfect squares would be like 4, 9, 16, 25, 36, numbers that simplify. So actually for this one, 64 is the biggest one that goes into it. It kind of takes me a long time to find that, and since this is a video, I just figured I'd go ahead and tell you that. I literally divide 1088 by each of those. So, in our picture now, the side is 8 squared of 17. The side is 8 squared is 17. This side's 26. Alright, so in my picture, one of the key things also for this one is diagonals are congruent. And they bisect. So if you remember, that makes all four parts of that congruent. So AC is the same length as DB. That's 42. EB would be, it's bisected, so half of 42 would be 21. BC, we know it's the opposite side, so that's 26. AB is going to be 8 squared is 17. Now we have some angles. ADC, that is a corner in a rectangle, and we know the corners are 90 degrees. ABD, so how can we figure that one out? Well, let's see. If I know this part here is 52 degrees, and if I take 90 minus 52, that makes this angle over here 38 degrees, which makes this angle 38 degrees. Or this angle, or this angle. So lots of ways to figure that out. I used knowing that this is 90 to figure out the 38, and then this is an isosceles triangle in here, and an isosceles triangle, those base angles are congruent. Okay, BCA. Well, that's alternate interior. BCA is alternate interior with that one, so that would be 52. DEC is right here in the middle. So what I would do to find this angle E right here, DEC, I would take 180 minus 38 minus 38. That's how I'd find that one. And we get 104. So lots of different properties of a rectangle there used. Next shape we're going to look at is a rhombus. Things to know about a rhombus: all four sides are congruent, the diagonals are perpendicular, and diagonals bisect the opposite angle. So ZY is 34. So we now know every side of this picture is 34. Okay, so let's see if that helps us plug anything in. So WZ we'll know is 34. BY is on a diagonal, ZB is a diagonal, ZX is a diagonal. Okay, so let's look at the next one. WY is 38. Okay, since a rhombus is part of a parallelogram, the diagonals bisect each other. So half of 38 would be 19. So this is 19 here and 19 here. So that helps us on one of these. BY is 19. Well, I still don't have the other diagonal. So, thing about a rhombus, this is perpendicular. Okay? So if I want this to just be x, we're going to use Pythagorean theorem again to find that length of the diagonal. So across from the 90 degrees is your hypotenuse. So on this one, 34 was my hypotenuse. I didn't mean to put that. 19 squared is 361. 34 squared is 1,156. So I will subtract those two numbers. We get 795. And then we need to square root 795. it's approximately, that's what the squiggly lines mean, 28.2. And I've done this one, 785 can't be divided by any perfect square. So 795 is considered a prime number, so we would just leave it like that. Okay? Or 28.2. I'll have to go back and look at the test. For some reason I'm thinking we allowed decimals on this. Give me 1 second to go back. Double check your test here. Because if we can just write decimals, I'm happy to write decimals on some of these. Make these numbers a little easier. Sometimes we have to simplify things. Sometimes we say, oh, it's okay to have. All your ones on the test are coming up to numbers that work nicely, so you don't have any of these weird ones like that. So let's just cross this out, and we're just going to do decimals on this. We're just going to say that's 28.2. The reason I'm going to do that is because to find Vx, you would take 2 times 795, square root of 75, and that's kind of complicated, so we're just going to do 28.2 times 2, and say this is 56.4. Alright, let's look at angles now. In an angle, opposite angles are bisected, diagonals are perpendicular, opposite angles are congruent. So let's see, WXZ, this angle right here. So far, the only one they gave us was ZXY. Y is 34 degrees. So, since this is in the same corner, and that was bisected, we know this one is also 34 degrees. WVZ here is at the center, so we know that's 90 degrees. ZYW, that's this angle down here. Okay, it's not going to be the same as these angles at X, okay? These are supplementary. So, if we know up here this total angle the whole angle at X is 68 degrees, because we doubled that. If you take 180 minus 68, you get 112 is the whole angle for angle Y. And they're just wanting ZYW, half of that. So I'm going to divide that by 2. So I'm going to say this one is 56 degrees. Alright, and then XYW would be the other side of that, so that would also be 56 degrees. So applying all those properties we learned or looked at during the first day to solving for angles and sides, or parts.